Alright, hello everyone. It's March 14th. Alright, let's take a look at what today's challenge is going to be. Before we start, old habit, going to take a look at the notifications. We got 5. Huh. I don't remember any of these, so we're just going to ignore it and let's go to it. Alright, it's going to be linked list. Should be something I'm interested in. The linked list is good. You're given the head of a linked list and an integer k. And you return the head of the linked list after swapping the value of the kth node from the beginning and the kth node from the end. The list is 1 indexed. Okay, so k equals 2. 1, 2. So we're going to swap 2 with 5. So we're going to swap 2 and 4. Okay. They probably have requirements. I mean, the immediate cheat is you turn this into a list. Oh my goodness. I feel so bad saying this. You turn this into a list, right? Into an array. You swap the number, turn it back into linked list. But we're not going to go there, right? We're not going to go there. The purpose of doing this is not to pass it, but to actually practice your skill. And in addition, if you really have this question in an interview, I actually think you should say that first, right? You should say that first. You should, of course, ask first, is there any requirement? And the interviewer, if they haven't really thought about this question very carefully, they're like, not really any requirement. They're like, okay, here's the solution. You copy everything into an array, you do the swap, you return it back as a linked list. And they're like, okay, that works. And could you implement like an O1 space, right? And then you do the real thing. So this is exactly what we're doing right now, right? We find out the cheat option, but then we should start thinking about the real one, which is to do it in O1 space. Now, O1 space requires just operations on the linked list. Let's just take a look at another example. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just swap 7 and 8. Yeah, if it's by itself, just swap by itself. Oh, okay. You can also do like this. All right, 1, 2, 1, 2. Don't change. Okay. So number of the nodes is 10 to the 5th. Okay. So O(n) in complexity, time complexity, and O(1) in space. All right. Let's take a look. Apparently, it's easy to go from the left to right. I can find the kth, right? So the problem is, how do we get the kth from bottom to the front? Now, there are many ways that I can think of. I mean, for one, if we know the total length of the linked list, and then we know from the back the kth, so we can calculate what is from the front, right? So it's basically the length minus k. So for this one, 1, 2, 3 of the 5. So it'll be the third one. 1, 2. Well, it's actually not the third one because it's indexed to 1 index. So it has to be 1, 2, 3, 4. Right? The fourth one from the start, which means it's the total number minus 2 plus 1. So total number minus 2 plus 1 will be the nth. The nth, that will be that. So we actually solved it already, right? We just need to go through it once, compute the total number of nodes that there are, and we go through it another times, and I pick out the 2 that we need to swap, and then the question is, I mean, it's again, it did not say how we should do the swap, right? We can just change the value, and we don't even have to make changes on the nodes. That's like another cheat, right? So we're not doing that. I'm pretty sure if you do that, you can do that like in an interview setting. You say, okay, I'm just gonna swap the numbers, swap the values, not do anything with the nodes, and it does work. And the interviewer like, okay, I think we have another problem. So let's say we cannot change the value, just swap the nodes. Now we have to swap the nodes. Now to swap the nodes itself, let's just assume that the values cannot be modified. So to swap the nodes, So we know if we are on this node, we can, no, we have to know the one previous ahead of it. All right, so we need to know we actually don't even need to know the node itself. We just need to know the node ahead of it. All right, so we can say this next equals this next, right? And then after do that, this next equals, we probably should still know that. Okay, so we need 4 nodes, right? We need this one, this one, this one, and this one. Will make things easier. So we say this next equals this next, all right? That removes this, and then we say this next equals this, and we say this next equals, all right, this next, I mean, okay, I'm kind of making it a bit complicated. I think this is solvable. This is solvable. So is this how we're going to handle it? We need to have 2 nodes, right? 2 nodes we have to know, which means we only, I mean, if I know this node, I'll know this node immediately, which means the actual node in the search for is this and this. Okay, so we're gonna put a dummy node just in case we have this situation. We're gonna put a dummy node, and we're gonna search for the k-1. So go front, back, k-1. Go back to the front. It's gonna be the total length minus the total length minus k. Yeah, the total length minus k, right? So it'll be 0, 1, 2, 3. K minus 2 is 3. Yeah, so we get these, and then we can start our magic. Not magic, just, trying to do the swapping, which I think will work, but it probably would take a little bit more effort than I had expected. There's some twists and turns we need to work with. So anyway, we can copy this, and we're going to run basically 2 loops, so it's not too bad, and we're not going to test it locally. So we're going to say n equals 0, and while head, we should say node equals head. While node n plus equal 1, node equals node.next. Right, so this is the first one that we are trying to find. And then we're going to say k. So we're going to say count. We're going to say count. So c equals 0. So this we get the total. Yeah, this is get a total number, right? Total number. So we have our target. Target is k, and n minus k. Actually, no. Target is k minus 1 and n minus k. And because I'm also going to have a dummy, dummy equals list node with next equals head. So that's the dummy. And we're going to say node is going to equal dummy. All right. Now we're going to look for while dummy, while node. If count equals k minus 1. So we're going to have 2 things, which is left and right, pre-left and pre-right, right? So to indicate that these things are the right and left node that before the right and left node, right? If it's this, then we say pre-left equals node, and elif c equals n minus k, then we say pre-right equals node. And once we find the pre-right, we can just break. Right? We don't need to continue going. If not, node next. All right. So now we have the pre-left and pre-right, which means we have the 1 and 3. Now we're gonna do our magic. How do we do our magic? We're going to identify. We're going to identify a few nodes just to make things easier. So we're gonna say left and post left equals pre-left dot next, and oh, that is not a good idea because we might have trouble like with this, right? With this, we have a pre-left, and pre-left will be here, and pre-right will be 1 minus 1 is 0. Will be pre-left and pre-right will be the same node, right? Will be the same node. So the actual node we have and the next node, oh, we actually do have. We have all of them. All right, I think that's actually good. Left and a post left. I mean, the post left is just going to be like, you know, like none, right? So that's going to be pre-left dot next and pre-left dot next dot next, right? And then right and post right is going to be pre-right dot next and a pre-right dot next dot next, right? So now the job is to rearrange them. So the rearrange deal will be pre-left, and I'll say rearrange. So to be pre-left dot next equals, we're gonna skip left, going to post left, right? And then we're gonna say left, right now left is still pointing to post left, and then pre-right dot next equals post right. Now we just get the left and the right out. Now when we get the left and the right out, we need to reconnect them. Oh, what are you doing? Pre-left dot next is not equals to post left. This is just to get it out. This should be actually equal to right. I was wrong. It has to equal to right. And then right dot next equals post left. There we go. That's how it's supposed to be. And pre-right, it should be equal to left, and then left dot next equals post right. Do we miss anything? So pre-left going to the right, that's good. And the right equals to post left, that's good. And then we basically take the right out. And the pre-right dot next equals left, that's good. Left on, I think we're good here. So once we're good here, we only need to return. We're gonna return dummy dot next. We're gonna leave the dummy node there. That's fine. So we just need to return the. So we're gonna put a little bit more nodes. So the first one will be find the total length of the linked list, right? And then this one is identify the nodes right before the target nodes, and then we rearrange. All right, let's throw this into into here, and run a couple of examples and see if it works. So the first one, it says does not work. All right, let's take a look. Why does it not work? It says none type does not have next. I thought we don't have that situation. All right, let's take a look. We have 2. The total value should be 1, 2, 3, 4, 5, right? We have 5. So the n should return 5. We have a dummy node with next equals to head, and our node is on the dummy, right? So when we go k minus 1, k is 2. So 2 minus 1, oh, because you did not increment c. Every time you go, you have to increment c. I don't know why I forgot that. And this one pass, and we're just going to go through a few more examples that's provided. I have pretty high confidence for this to work. Gonna do this to let it run. Find cycle in the linked list. Ooh. Okay. Apparently it's not working. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Why is it not working? Because I said 6 is the pre-left, 7 is the left, 8 is the pre-right. No, 8 is the post-left, and 7 is, oh, that is the difficult part. Now I see. It's not as simple as you think. 7 is both the target, both the left and the pre-right. Now when we say pre-left, dot next equals right. So 6 linked to 8. And then 8 dot next linked to post left. And post left is 8 itself. Ooh, this is not as simple. How is that possible? Post left. Yeah, it is possible. Okay. It is not as simple. All right, let's rethink. The thing we're sure is we can find 6 and 3. This is the pre-left and post-right, right? So pre-left we can clearly identify, and the post-right we can clear. So we have our target, we can call it left, and another target is right. And our algorithm can find the left and right uniquely, and it can find the pre-left and the post-right uniquely. But these two, the post-left and post-right, no, post-left, it's actually post-left and pre-right is a little bit muddy. The post-left and pre-right is a bit muddy. Now, if the post-left and the pre-right are not the same node, then our algorithm shall work. Right? The post-left and the pre-right are not the same, but they could become muddier. Right? They could become muddier if they cross paths. Right? Say, like if I'm gonna just draw it out. I'm gonna draw it out, which you guys cannot see, but this is how I think. So we have pre-left, post-right are good, left and right is good, and then we have something in the middle. And the ideal is to just cut some ties, and then the right dot next equals to post left. All right, equal to post left. But it could be that the right is the post left itself, and then we have a cycle, which we do not want. Now, is there a way to avoid that from happening? Apparently, there should be, right? There should be a way to avoid that from happening. It depends on how many nodes are in between our left and right, right? So if we identify the left and right, which we will do, we identify the left and then we identify the right, and we identify the node right before the left, and then we identify the node right after right. So these nodes are pretty sure that we do not have any trouble with them. Now, can we use this information just to help us swap the left and right? We probably, so we identify them, and in order to swap, the pre-left has to point to the right, right? There's no problem with it. So pre-left has to point into right, and the right has to point into whoever is after the left. But it is important that the one that's after the left is, as long as there is anything separating left and right, as long as there is anything separating left and right, then we shall pointing the right to it. Anything that first appears, right? First appears. And the only trouble we have is if left and right are adjacent to each other. If they're adjacent to each other, then we have an issue because the right will be pointing to the right itself. So we have to go, oh, we cannot even go past it because in that case, if they're adjacent to each other, then the right should be pointing to the left. All right? That's how it's supposed to be. So I think it's just the order. We just need to fix the order. Pre-left point to right. Right pointing to pre-left point to right, and I say right pointing to post left. But instead of saying right pointing to post left, I say left pointing to post right. These are certain changes, right? These are certain changes. Now we have so this link is done. So now we have the left pointing to or the right. Now we want to point in the right. How do we point the right? We say right has to pointing to the post left. Now right has to pointing to whoever is after the pre-left. So it's pre-left, the next. How do we handle this? Is this like a special case we have to handle separately? If we have the two, left and right, are adjacent to each other. We know that if there are anything, right, anything that's in between left and right, this algorithm should be correct, right? So we say pre-left on next equals r dot next equals post left, and pre-right next equals to left. So we now have PL to R to the star, and the star next equals to left, and which means this one here, this one cutting, and left equals yes. As long as there's anything in between left and right, this algorithm shall work. It does not work if left and right are adjacent. I am pretty sure that left and right, this will also not work if these two are the same by themselves. Actually, it's fine if they're the same. If they're the same, that shall work, which means this case, 1, 2, 3, and 2, this case shall work, even with this algorithm. It shall work. Ooh, it does not work. It does not work. Oh, I have a lot of issues. Why does it not work? I have 3, and the target is 1 or 1, right? So once I come out, because these two are the same. Interesting. Let's just, be a good lad and do not break. Just go with it again. Just in case, right? Just in case. Just in case. We get the 2, and this one shall work. Yeah, this one shall work. And we have to also handle this case. So basically, we have the node identified. And the only trouble we have is when they are adjacent to each other. And probably in this situation when, it is like reversed. Like it's actually not this. What is the k requirement? Yeah, we can be like k. K could be just boldly. Let's just try. Oh, we can actually have, yeah. And if our k is too big, that's actually fine. Say 1, 2, 3, 4, 5, 6, 7, 8. Let's say 8. I think this actually shall work. Yeah, it's work. It's working. So the only thing that does not work is 5, which means they're adjacent to each other. So how do we prove that they're adjacent to each other? Well, pretty simple. After we done this, right, we got the pre-left and pre-right. All we need to prove, so special case is when left and right are adjacent. So that's the only case we care about. So to prove that, so we just say if pre-left, right? If pre-left, all right. So pre-left is before the left. Hold a sec. There's also a trick. So we need to make sure k is the smaller one. K is the smaller one, all right? So k has to be the smaller one. So we have an idea, left has to be on the left side, right has to be on the right side. But if the k is a big value, then it won't work. So if k is a big value, let's just say k is 8, right? K is 8. K is 8. The whole thing is, I forgot how many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 minus 8 is 2. 0, 1, 1, 2. So it's going to be this value and 0, I'm going to have 8, and I'm going to have 2, right? So 1, 2, 3, 4, 5, 6, 7, 8. And the other one is counting 1, 2, 3, 4, 5, 6, 7, 8. Has to be here. Has to be this one, right? So which means we're counting 7. 7 is here, and counting 2. So 2 is here. So 7 and 2, right? So we need to pick the min to be, yeah, we have to have a little bit of trick here, which means we're gonna have left index, pre-left index equals the mean of n minus k and k minus 1 and the pre-right index. This is avoiding the issue of them crossing, right? So we use this to avoid the issue of them crossing. So with this, we can be very confident to say that it's going to be pre-left index, and this is going to be pre-right index. Well, this and not pre-left or not pre-right, right? So when both are done, then we just get out. We get out. So that's why we don't have to check here. We just check here. Okay. So special case will be the pre-left is actually on the left side. So they're adjacent, right? Adjacent, which means pre-left dot next is the left equals is pre-right. Right. This is when they are adjacent. Pre-left dot next equals pre-right. So this is when they are adjacent. So if they're adjacent, then the swap becomes pre-left. How do we do this? Then the swap becomes pre-left dot next equals to the right, right? Pre-left dot next equals right, and then left, and then right dot next equals left, and then left dot next equals post right. Right? So we can still do this. So this is still fine. This is necessary. Just when this happens, we can say pre-left dot next equals right, right dot next equals left, left dot next equals post right. Else, which is there are at least one node between left and right. Then we do this. We do this trick, and we return at the end. And this one shall work for this. Name, what did I do? Which line? 23. What did you do, man? Underscore. There we go. Now we're talking. Now we talk. So we can submit this. Oh, we haven't checked everything, but we passed. All right. I forgot to check the final too, but I guess it's fine. Yep. I mean, it's not really, I should say, difficult, but there is this edge case I have to consider, which makes the code looks a little bit, just odd and ugly, and I don't know. I don't like it. I feel like there must be a better way of doing this. Right? There must be a better way of doing it. And let's also make it more clear what we're doing here. These two are the nodes right before the ones to be swapped. Right? And this, actually, let's just put this comment on top. Let's make it nicer. And these two are to guarantee that the left and right nodes, the left node is definitely on the left to the right node. This is to prevent any complications. Because if it's not, then let me think. If it's not, will this prove to be complicated? So we say, what if the left node is on the right side, and then if the left node is on the right side, then this one will not work because the pre-left on next will never become right. So we do have to use this trick to make sure that our left and right are correct. And then we search for the pre-left and the pre-right. Once this one is done, we are going to actually I want to reduce a line, so I'm gonna do it here. Yeah, I feel like reducing a line is a good idea, right? We're gonna do it here, so we can remove this line and remove this line as well. Locate the previous node before left, and this is locate the previous node before right. Right? So we get these two, and then Let's see. This shall be all correct. Let's see. And then we have this. I'll consider a special case, and then we consider the actual case. And actually, the only difference is the internal, which means the only difference we need to make is, for this one we have to do for both, right? So we can put this at the end, and this one we have to do for both, all right? Put it at the end, so we can delete this one, so it'll be like this. So if they're adjacent, we just say right dot next equals left. If they're not, the right dot next equals post left next. Exactly. And then the outer is always the same. Okay, so we save a few lines there. And finally, I'm not sure, but can we use Walrus here? Which means we say node, Walrus, dummy. Does that work? Let's comment out this. And here as well, we say node, Walrus head. Comment this out. Let's run it, see how it works. I'm trying to save as many lines as possible, so it would not look as bad. And it's not working. Alright, so I think we changed too much. So the Walrus ID does not work, which is fine. We just leave it there. Yeah, we'll leave the dummy there. That's fine. But we can combine these two into one line. That's a kind of the easy one. Just combine the same thing. We'll say C, node 0 dummy. Alright, so we save 2 lines. And there's nothing else to save here. Everything is fine. This is fine. Okay, so I think this is my final solution. This must be timeout. Yeah, please timeout. And this is the same. This was slightly different. Did you run? Oh. I did run. Oh, I added C. What the heck? Why you put the capitalized C? Don't understand. You must complain like C does not exist. Alright, then we submit. And shall pass. And then let's take a look at the runtime. We probably should go for the first runtime. This is the second runtime. Second runtime usually is worse. Let's take a look at the solution. No solution. Let's take a look at the first runtime. First runtime is always better than the second one. I think that's like why they're trying to encourage you to do the first one, I guess. It's a medium question. I don't think I've done it before. Yeah, the first runtime is better. Even though the two is actually exactly the same. So we're going to use the first runtime as our way of doing this. Who did it with this? The heck? Oh wow. Can be done so easily. Oh, it just swapped the value. We do not want that, don't we? Oh, and then also, oh, okay. Oh, you record the nodes? Oh, okay. Ah, ha. This is even worse. This is even worse. No, I shouldn't say it's even worse. This is actually quite smart. It's combining my two cheats together. Alright, so it put the node into an array and then swap the value and then return the head. Let's ignore all this. Anyway, so we have discussed that this problem can have a few cheat ways to solve. But most likely we won't be able to use the cheat method, say in an interview. So we need to. So we wrote a true solution, which is O1 in space, however, it is important to know that if you encounter this in a competition, you 100% go for the easiest. You copy it into a list and then you swap the value and then your turn. That is the way to go. However, in interview, I'm pretty sure you will get follow-up questions on this. The ideal of this true solution is to identify the nodes to be swapped and then swap them. The trick is when there are two tricks, right? There are two tricks. First, if the nodes to be swapped are adjacent to each other, the algorithm for swapping is different from when they are not adjacent, or if they are the same node. Second, it is possible that k is a large value and the left and right node will be, and the left node, I'm going to put a parenthesis on it, and the left node could be to the right of the right node. Once we have handled these two tricks, the solution is quite trivial. I should say trivial. The solution is not difficult. All right, so this one we run an ON. Technically speaking, we should put an O2N, right? This is exactly what we have. So we run the whole length twice, and then, yeah, it's such ON. I just put ON, and we run a 1092 milliseconds, and this one gives us oh, I forgot the what does it give us? It gave us 67% ranking, which is meh. Let's take a look if there's any good solutions. Go discussion. Oh, one pass. You can do it one pass. That's why it's faster. No need in 2 pointers. Oh wow. So what does one pass do? I don't like this idea of using this, but again, we're doing one pass. Alright, let's take a look. We reach kth node, we set the current node, okay, and N2 to the head. Continue traversing, but now we also move N2. Oh, that's the smart part. That is the smart part. But no. They all using the cheating way. They all use the cheating way. But this is the right solution to find the kth to the end. This idea of resetting the head, we need to remember that. This is a good solution. We reset the head. So basically what it's saying is, in the linked list, we just iterate through to the kth, right? To the kth, we find the kth node, and then we're gonna basically reset. Not reset, right? I mean, how should I say it? We reset the node to the front. we put another node. So once we get to the kth node, we're gonna put a new node to the front, and then we keep moving forward. Then once we reach the end, then the new node we put at the front will reach at the kth before the end. So that is the idea. And because they use a cheating way, which technically, I mean, yeah, that's fine. Let's write it in this way then. It'll be interesting. So 2 pointers, no need in 2 pointers. How do you do it without 2 pointers? You still do 2 pointers. Right? Begin. So you get a left, and then you reset right. That's 2 pointers. That isn't that 2 pointers? That is 2 pointers. Well, 2-pass solution just, yeah, that's, yeah, exactly. Oh, really? It calls for swapping values. I'm going to upvote that because that is correct. But maybe I didn't read the... No, it says swapping nodes. You have to swap nodes. You cannot just swap values. You have to swap nodes. Because swap value is just too easy, right? It's just too easy. However, it is possible to do it in one run, so we're going to do that. We're going to do in one run to find the left and right. However, it will be challenging because we don't actually know where. So we'll get to the left and right. Well, not really left and right. We get to the 2 nodes, right? We get to the 2 nodes. Or specifically, we get to the nodes right before the 2 nodes, and then we are not sure which one is on the left side and which one is on the right side, which means we still have to keep counting. We still have to keep count. So this one still works. So the only thing changing, we can actually write it. The 1 pass to find them, right? To find them. I mean, we are setting up ourselves for a harder challenge because we are not allowing ourselves to swap the values, which is, it's fine. So, but it is a good practice, right? We still need this, and we're gonna go to k-1. Yeah, we're gonna go to k-1. So we're gonna call it a left. We're gonna call it a left, pre-left. We have to do this first, right? I'll do this first. Do this first. Get the node. It's gonna be dummy. And if we want to have n, so n has to be -1 because I don't want to count the dummy. And then while node, so n is keeping track, right? N is keeping track. N has to be equal to k-1. Yeah, and but if k is 1, so n has to be 0. This has to be 0. Actually, this has to be c, right? C, it has to be c. And we say c is here, count. And then we say if c is smaller or equal to k-1. And then we'll keep going, and then it will be equal to, and then we're going to say, actually, it's not a good idea to set it here. I want to set it inside. So C, we're going to first check if C equals k-1. Then we're gonna say, let's just call it pre-left, right, equals node. And after done this, we're gonna break. Do we break or do we set a new thing? Let me think. Yeah, we set a new thing. We actually do it in one. Like I said, it's gonna, like they said, it's gonna be a one pass. So we're gonna put this one here, right? I'm gonna do this. So if count equals this, so pre-left equals node, and pre-right. Pre-right equals pre-right equals what? Equals head. No equals dummy. So one, the pre-left hit the node, right? Hit our target, and the pre-right is gonna start from the beginning, and the node is gonna keep going. And this only being set once, and then once it's done, once it exit, now we have the pre-left and pre-right. Now we have pre-left and pre-right. We need to be sure that the left is actually the left and the right is actually the right. How do we make sure? We make sure by doing this check. We say if, because C is the total number plus 1. So we just say if C minus 1, that's the total length, minus K, right? That is the count from the left to get to the right node. So if this one is larger, no, is smaller than the K minus 1, then we need to swap, which means pre-left and the pre-right has to swap. Pre-left. Now we can do this. Now we can do this rearrange. We call it rearrange. Right, now we do the rearrange, and then we'll return. So this is one path. One pass to find both pre-left and pre-right. One pass solution to identify the nodes to be swapped. Right? You want to put a reference? Yeah, let's put a reference just in case. I mean, all of them are talking about it, so I just need to, let's just put the first one. Reference. One pass. And we're going to go to submission. Take a look at this. We're going to run some test cases. See if it works. Found cycle in the list node. Why is this not working? It's not working because I don't know. It's not working. I did this check, right? I did the check. C minus 1 is n minus k should be, if k is a small number, so k is a larger number, I am swapping pre-left and pre-right. Why is this one not working? Did we find the right node? I think so, right? Oh, because you forgot to increment pre-right. So we've identified it. We identify it as, so we get the pre-left, and then after we get a pre-left, we got a pre-right, and then we're gonna increment on to the next one, which is fine. So we're gonna do it here. Equals if pre-right equals pre-right, Dot next. Yes, that one shall work. Oh, what the heck? That one is still not working. Whew, whoosh. Sheesh. It's giving me trouble. The same trouble. Alright. It's not straightforward, huh? Alright, so we put a dummy, right? We'll put a dummy and then k c equals to 1. We wait for c equals to 1. So now the node is here, alright, and then c equals 0, goes inside, c equals no, so c plus equal 1, node, move here, pre-write is none, so we don't do that. And now c equals 1. C equals 1 now. C equals 1. C equals 2 minus 1 is 1. So left node equals this. Then pre-write equals dummy. And then come out. And then C gonna move on to this one. And node gonna move on to this one. And pre-write, now I have pre-write. Pre-write gonna move on to this one. So pre-write is this, node is here. Coming back up, see, move on forward, node forward, pre-write, no forward, pre-write, and then we're gonna move on again. So at here, c plus equal 1, node equals to no, it becomes none, and pre-write, boom, we end up here. That's why it's not right. So that means the pre-write cannot go. Pre-write cannot go. So node next has to go first before pre-write goes. Is that what it means? But now what happens is we're always tracking. Right? So what we need to do is to end like this. Don't end the node like at the end. Don't end the node at the last node. And this one shall work. Can we run like all of them? Use example test cases. Exactly. Yeah, like this. I have some confidence in this one. It is still not correct. Alright, let's just run one of them. This is the first one. No, the first one's still not right. Oh, I'm running all of them. Never expect to have so much trouble with this one. It's wrong answer. What I'm swapping to the last one. Why? Why would I swap to the last one? I'm already saying no dot next, so I'm stopping here, which means pre-write should be. Oh, pre-write should be here. Jeez, that's the target. Pre-write should be here. Man, oh yeah. So I'm targeting, yeah, it should be, oh my goodness, we need to have 2 dummy nodes. Oh my dear God, we need 2 dummy nodes. Because when we start, when we put the pre-write has to be on the dummy node. Now, like, not even on the dummy node. So the dummy node is like the, wait, why? I should be able just to put on a dummy node, right? I put on a dummy node. When I put it on the dummy node, the current node is here. Dummy node is here, current node is here, and that is pre-left. And as the pre-left, and this one, oh, so it has to end at the pre. Hold a second. What is the actual what's the solution that they're promoting? What they're saying is, if I go to the second one, 1, 2, right, I get here, and then I put the node here. So when I reach the end, the target, this one will go here. So they go side by side because the number of nodes in between is the same as this. And then we get here. So we have the left and right. Okay, so that's what they're saying. Now what you're saying is, I want to identify 1 and 3, right? 1 and 3, which means we need to go for k minus 1, which is 0. K minus 1, wait, k minus 1, which is 1. That is what we want to have, is 1, right? Is 1. So when I hit here, why does this not work as well as how the other thing is? Because now k equals 1, and when you reach the end, how do I get the other one here? It should be the same, right? So just like instead of looking for k, we're looking for k minus 1, right? We're looking for k minus 1, which means doesn't mean anything. It just means it's not going to work because it's not symmetrical. We're doing the one node ahead. It's not symmetrical, so we cannot use this method. Yeah, that's the reason, because it's not symmetrical. The k is saying the kth and the kth from the right. But now we're saying the k minus 1 and the k minus 2 from the right. That's why it's not working. Can we make it work? Can we make it work? We want the k minus 1th from the right, from the left, and a k minus, and also k minus 1 from the right, right? No, it's k plus 1. That's the thing. We want k plus 1 from the right. K plus 1 from the right. Which means if we did k minus 1 step from the left, and we need to add 2 more nodes to the left in order to get to k plus 1. Yes, so we do need 2 extra nodes on the left side. So we need to have a dummy, and we need to have a pre-dummy. So let's call it d-dummy. D-dummy equals a list node with next equals dummy, right? And then, oh my goodness, the node is going to be d-dummy, right? We're going to start from d-dummy. Unbelievable! This is unbelievable. We're going to start from d-dummy, right? So that guarantees that the length difference will be 2, right? At least 2. Oh man, this is stupid. And we're gonna end that here. So we're gonna be a d-dummy. So when we hit here, we are still at dummy, right? No, not right. Not right. This is gonna be different. We're going to start from 0. C going to start from 0. And, oh, this is tiring to think about. What's C going to be? So we're going to have 2 nodes in the front. So C going to be starting from here. So 0, 1, 2 is actually going to be K. We're actually going looking for K, even though we're looking for the front node of K. We're actually going to K. K is the front one, which means we're going to start from 0, and node is here, and then 1, 2, right? We get the left nodes here, and this one going to be d-dummy. So for the right node here, then we have 1 node in between, and once this one here, yeah, this one shall work. Capitalized L. Wait a little bit longer, run the code again. Yep. Let's run all the examples. Oh yes, we did all of them. and then we're gonna do submit the one pass. It is faster. It is faster. All right, we're gonna copy and paste this thing. Oh, this thing's actually harder than I thought. Is anybody talking about not doing the value swapping, but the node swapping? The node swapping is significantly harder. Significantly harder. Swapping nodes, swapping values. Swapping nodes. Dummy. Yeah, we have to use more dummy. Oh, he used only one dummy. How do you handle it? Dummy is pre-left, pre-right. Okay, that's what I do. Left and right equals head. Left and right is a head. We go to the pre-left. Okay. And node checker. A node checker. While node checker on next. Pre-right equals right. Right, going forward, node checker. If left equals right, yes. If not, we're gonna swap. Okay, I don't understand. So this is the one path, right? So in my case, I need to have two nodes for this. But he did not. He just have the left and then have a node checker. It doesn't matter what node checker is. So basically, this is go to the end, and the pre-write, while this the next has value, pre-write equals, so we're moving pre-write into the right position, and the right goes forward. Okay, yes, that's pre-write, and then that's right. We just want to find the right node. So we keep them together, and then we keep moving. So this is basically the correct logic. So they don't need to play with the C value. Hold on, so we find the left, and we keep them together. We keep the pre-left and the left together. So once we find the left, we find the pre-left. That's correct. And then, because it's symmetrical, so I can just start from the right. So we have the right and pre-right. Now, how do you, because the left and right could be an awkward position. You say if they're the same, you return, that's fine. But what if they are right next to each other? Pre-left. So if pre-left, let's check this algorithm. When, there are three situations that we need to consider. One is the left and right is adjacent. So the pre-left and the pre-right will have this serious problem. Let's take a look. So what we're saying is the pre-left dot next equals right, okay? And pre-right dot next equals left. Huh? Hold on, pre-right is here. Pre-right dot next equals left. Okay, so we're pointing to itself. And then left dot next equals right dot next. So this has a next. Left dot next equals right dot next. Okay. And then right dot next equals left dot next. Right dot next. Hold on. Left dot next equals right dot next. Okay. And then right dot next equals left dot next. Isn't left dot next pointing to the right? No, I don't think this one works though. Does it work? When was this published? Just a few months, just like last month. How does this one work? I'm curious. This one so far does not make sense to me. I want to run this test case. Definitely work. Solution is not defined. I forgot a solution, so I'm gonna comment out this, post this, and probably need to do one more like this. Yeah. And test case is going to be 1, 2, 3. 1, 2, 3, 4. No, not this one. Which one is the test case that you're looking for? We're looking for this one. This is the one I'm looking for. I run this. It pass? Dear Lord, it passed. But the analysis didn't really make it right. Left and right adjacent, right? So pre-left on next equals right, okay? Pre-right on next equals left. So this one make left pointing to itself. And then left on next equals right on next, okay? Left on next equals right on next, that's fine. And then right on next equals to left on the, oh, it pointed to the left. Oh, it does work this way. Okay. Then I think it's just the order of how I do it is not right. Hold on. How about they are on the other side? What if the left is on the right side and the right is on the left side? Pre-left next equals to right. So this one I'm going to point back to right. Pre-right dot next and point to left. Okay. And then right dot next, left dot next is going to be right. So this the right dot next, and the right dot next is going to be, oh, this actually works. I mean, even in my case, I think it's going to work. I don't have to check. I'm not sure. I'm going to take a look here. I'm going to take a look right here. This one works. I think, yeah, I know this one's all right. I think I don't have to do this check. Oh, this one definitely works because the left and right is correct. What I'm saying is, let's say we have 8. Does it still work? Alright, too soon. It shall work. It shall work. Yeah, it does. Why did I think it does not work? I don't know. I really don't know. It does work. Left and post left, right? We have left and post left, right and post right, even if they're not in the right position. Pre-left on next. No. Right down next. Right down next equals post left. Okay. And then pre-right down next. Pre-right down next equals left. And then we say pre-left down next equals right. And then left down next equals right. Yeah, it does work. Why do I even change it? So this one does work. Okay, we're gonna write a new one. No, we're gonna just like, this one work. We don't have to check. Okay, so that's one. What if they're adjacent to each other? This made me think maybe we can even do it even if they're adjacent to each other. When they're adjacent to each other, what happens is we know that these two can still do pre-left dot next equals right. That one's still right. Left dot next equals post right. That's still right. is just here. I say right dot next equals left instead of right dot next equals post left. This one will point to right itself, and then pre-left dot next. Pre-left is going to be pre-right is going to be left, and that one is going to point into itself as well. And then we say, hold on. So basically, right dot next equals post left will pointing right to itself, and then pre-right dot next equals left will point left to itself. And then I say pre-left dot next equals right, and then I say left dot next equals post right. Left dot next. So I break one. So the only thing I need is right dot next equals right dot next equals left. Right, I just need right dot next equals left dot next, which means I think if I swap this order, then it works. Pre-left, right? Pre-left, no, pre-right dot next equals left. So my left is pointing to itself. And then right dot next equals post. I should not do post left. I shall do left dot next. That is the trick. That is the trick, because you singled it out, then the dynamic happening cannot be reflected as you are making these, points. But does the order not matter? I think the order doesn't matter. No, it does not matter. So, which means instead of doing all this, we do need the left and the right. We need left and right, that's for sure. And this is going to be pre-right dot next, right? But we don't need a special case. All we need is pre-left dot next equals right. That's true. Left dot next equals post right. That's true. And left dot next is equal to, right, the left dot next. Oh, we already done left dot next. It's right dot next. Right dot next shall equal to left dot next. Right? Right dot next equals left dot next. But we have to first find left dot next. Left dot next equals post right. That's true. And then it's the pre-right. Into pre-right. Pre-right dot next equals left. Yes, pre-right dot next equals to left, and then right dot next equals left dot next. That's the case. And once you see this, post right, there's nothing as post right. This is going to be right dot next. Now we converge into the other solution. That's the same. That's the same. And then we can make even further changes. Just instead of doing, C equals a C plus 1 like we are counting, we still need to count. But it will be, no, we don't need to count. So we just need a dummy node. Just one dummy node. Because when we count the numbers, right, then we have to, become more complicated. But we only have a dummy, then things will be different. Let's just first find the left and the pre-left, right? So we're going to say pre-left and the left equals dummy and head. right? And then I like how that node was for I in range. Actually, we don't even need I, underscore in range, k minus 1. So we want to find, actually, it's at k minus 1, or we are going from here. So 1, 2, 3, right? So how many steps? 1, 2, 3. 1, 2, we go 2 steps. So this is the number of steps. And every time we do it, it's going to be pre-left equals left, and then left equals left next. Right? So we walk until we finish. Now we have the left. Now what we're going to do is we're going to say node equals left, and then we're going to say pre-right, right equals dummy and the head. And then we say while node dot next, when you do pre-right equals right, and right equals right dot next. Once we go to the end, we have pre-right and right, so we have all of them. And then just rearrange. Oh wow, this is a much better solution, I have to say. Let's try it on this. Oh, because to do node equals node on next. Because we don't need to do this again. Right. That's sure, because we have left and right. Right equals right equals right on next, and we move node forward. Pre-right and right. How is this not right? Pre-dot left. I think the order matters. In this case, 1, 2, 3, 4, 5, 6, 7, 8. So it's the left is here, and the right is here, or the left is here. So we say pre-left dot next equals to right. Okay. Left dot next equals to right dot next. That's fine. And pre-right, it should be here. Dot next equals to left equals this. And right dot next equals to left dot next. Oh, why is this one wrong? Let me do a better job here. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then after finish, let's just print out the pre-left dot value, left dot value, print pre-right dot value, and then right dot value. Just kind of see how it looks like. So the pre-left and the left, pre-right and the right, that's correct. That's exactly what we want. And then I say pre-left, which is 7, dot next equals right. So this one will be pointing to 3. That's fine. And then left, which is 8, dot next equals to right, dot next. So this one will point to 4. Yeah, that's fine, right? 8 will point into 4. 8 should be pointing to 4, because right, the left dot next pointing here, and then left dot, and then pre-right is 2, dot next equals left. So 2 and pointing to 8, which is correct. It's 8 pointing to 4, 2 pointing to 8, 8 pointing to 4. And then right dot next equals left dot next. Oh, I already done it. Left dot next is changing to right dot next. Now right dot next pointing to itself. So we need intermediate, or we just need to, yeah, we need to have them do it this way. The intermediate shall be created as a this, and we probably can do it this way as well. Right, left. So left, dot next. Okay, now try it again. Yep, there we go. And this is actually exactly the same solution as the one offered in the, actually I want to do just this. Let's also run test cases here, use example test cases. Make sure everything still pass. Does, and we're gonna submit. This is actually not inspired by this. It's inspired by this one. Very good. Very, very good. Submit. Yep. I'm gonna say this is a better way of doing the. This is apparently a much better way of finding the target node and making the swap. It avoids all the edge case checking that I have to do. It is really, to fully understand it, we have to draw some diagrams. Yeah, this is the finding, the one pass finding is here, so we should actually notify it. So we're gonna say this is one pass to find pre-left, left, and pre-right, right. So one pass to find, and this is swapping. Swapping without the need to check for edge cases. That's pretty brilliant. So just pre, if you think about it, that's correct. Pre.next equals right, and pre-right equals next. And pre-right on next equals left. And then we swap the left and right, their next pointing. And then we're good. Brilliant. Very brilliant. All right, that's it for today. I mean, we did solve it, but it's clunky. We used 2 pass, and it's definitely not the best solution. And this one's very good. This one's very good. I like it. I like it a lot. 1 pass to find the left and right, clean, very clean, and using very good way to do the swapping. Oh yeah, he have this. Left, right, yeah. And I consider this situation as well, yeah. Very clean. On the node swapping. Very clean. Beautiful, beautiful. All right, that's it. That's it for today. See you guys tomorrow. Adios.